pleased to have Professor Nevile Kallenbach and his granddaughter Lily Newworth here. It's our first joint presentation this semester. Hopefully not the last. Nevile and Lily are going to talk about a major environmental problem, and they hope not to be interrupted by phone calls.
I turned mine off.
Phones off. Phones off. And also, I'd like to remind you, if you would like to ask a question, which you are more or less welcome to do, please use the microphone. I know you think you can be heard in here, but we have worked really hard with our tech advisor, Ed, to make these videos available for you, for people who can't get here. So that's why we need to use the mics, so people who watch it later, which you can also do, to say, I didn't quite get all that, I'm gonna watch it again, in order for it to be audible, okay? Thank you. Over to you, Duo.
Am I muted? Hi, Ed. We need some unmuting. Can you hear me now?
Yes.
Am I too loud? So today's presentation is about an unpleasantness. And so in order to mitigate that, we invited Lily Newworth, who's more decorative and pleasant than I am. Anyway, so the talk is in three parts, like all. I talk about some chemistry, a lesson in chemistry that's not the same as the book. And it's because this is for English majors who haven't learned about molecules and atoms. And it won't be very long. And then we'll go on to the main topic. So that's for Harry. So toxicology is the study of poisons. Poisons are anything that is bad for you. So you know, starting from the apple in Eden. So in the United States, toxicology is carried out by OSHA for employment and employees who do actually a lot more than EPA to worry about safety. The EPA controls the Environmental Protection Agency, as it's supposed to be, and the CDC is the Center for Disease Control. So those all have websites that contain enormous amounts of information that beyond what anyone would want. But if you think about things that are bad for you, the EPA classifies toxic agents. So lots of heavy metals, copper, cobalt, lead are toxic. Solvents and vapors that come from organic gasoline and so on. Radioactive materials have been controlled for a long time. Dioxin, furans, organic chemicals that accumulated in the environment. Lots of pesticides that we still use. Plant toxins and animal toxins. And notice that neither plastics, microplastics, nor PFAs are listed here. So they're really quite recent additions to the concerns. So this map shows two dots that you can see. One big purple, that's the industrial area in Philadelphia. And the little dots around it, if you can see them, are where the EPA has sites that they're worried about and that have to report contamination. We are in that little red dot way over there in a relatively safe environment. But if you live closer to one of the industrial zones of Philadelphia, you're at risk for lots of contaminations, including lead and organic material. So toxicology started with this man called Paracelsus, who was a very interesting person. But he was the first person to notice that the dose makes the poison. People didn't understand about concentration and about anything else. But the importance of that is that we have to talk about maximum contaminant levels. The EPA is trying to set, and the OSHA is trying to set the maximum contaminant level that is tolerable. And so that means it's a question of a dose. How much of a dose makes a problem a problem? So what are PFAs? I think most of you have seen some of this. So they're called per and polyfluoroalkyl substances, a group of thousands of man-made chemicals that have been used in lots and lots of industrial products and household products since the 1940s. And as Lily will show you, they were patented in the 1930s, late 1930s. The reason that we're concerned with them is that they last for a long time. They're called forever chemicals because they don't break down in the environment by any natural process. Nothing can eat them. And they accumulate in people, animals, water supplies, and the environment over time. And because of their persistence and their potential health risks, all of us have to be concerned about them at some point. But I don't want you to go home hysterical. So first of all, we have to discuss molecules and atoms. So atoms are things about a trillion for the size of a meter. They're tiny, and they control a positive nucleus, which is heavy, and a very light electron that flies around them. That does not look like this because that's a complete simplification. The problem with teaching chemistry is that most of it isn't right. And so I lost somebody here. So
wait, hold on, the screen's.
go ahead. It's a good thing someone knows what they're doing here. Okay, there. I lost helium. There it is. So helium is the next biggest atom. Hydrogen and helium are the most predominant atoms in the whole universe. And so as nuclei get bigger, they add things called neutrons, which are not charged, but they add mass to the nucleus, and the electrons essentially still fly around. So this, all matter that we know about in the whole universe is made from about 100 different atoms, which are each called an element. So oxygen is an element over here. And this column of reds
You
are...
can see when you point on the screen.
Good thinking. I wasn't supposed to point. I'm not going to point. So the red column at the left is sodium, potassium, and so on. So that's what makes salt, sodium chloride. The people in purple here are very special. They're not purple, they're light blue. And I lied. Helium, neon, and so on. Oh, whoopee.
There's that, just in case.
Oh,
Let me move your mic out just a little bit.
oh. Okay, moving mic. Okay, so anyway, almost all the elements in the periodic table are metals, which I'll tell you about in a second. Free atoms almost never exist, except for this row of light blue people at the right-hand side of the periodic table: helium, neon, krypton, which is bad for Superman, and xenon. So these all exist as isolated atoms and don't interact with other atoms at all. Almost every element in that table, other than a few areas, can be metals. That doesn't mean they are metals all the time, but a metal means that the nuclei are all positioned in a lattice and the electrons are free to fly around between them, among them. And so you can pass charges through metals because the electrons are essentially free C. So molecules, specific molecules, result from bonding between atoms. So hydrogen is two hydrogen atoms bonded together. Oxygen is two oxygens bonded together. Water is H2O, you can see. And so these are the common elements in that, common things we know about in our environment are molecules. So if you look around you, most of the things around are molecules, not metals. So bonds between atoms vary very much in their strength. What I mean by bond strength is the CF bond, carbon-fluorine bond, is exceptionally stable, and therefore it's a strong bond. The CF bond is known because it's a very high bond dissociation energy. That means you have to put a lot of energy in to break it. And the red stuff you can ignore because it tries to explain why CF is so strong, but it's just strong. So methane, which is a big environmental problem you know about, is CH4, and tetrafluoromethane would be CF4, and the two molecules differ enormously in their properties. The shape of both of them is tetrahedral, which is surprising. You would think that they would be a square, but they're not. So the tetrahedron is essentially where the red lines go in this diagram, but the atoms are in the middle. So they form this thing called a tetrahedron, and it turns out that it keeps the hydrogens further away from them than if they were in a square or plane. And you can demonstrate that very nicely with balloons. If you tether 4 balloons together in a square and just let them wiggle, they pop into a tetrahedron. Yes. So
We want a demonstration.
you have to have a microphone to make comments. So suppose you make a single, instead of a single carbon-fluorine bond, but you polymerize, you add many of them together in a chain. So polymers are chain molecules, and many, many things around us are polymers. All plastics are polymers, for example. So here's numbers. The energy required to form or break methane is 75, whatever the units are. And the energy to form CF4 is more than 12 times bigger than that. So essentially, PFA molecules consist of repeats of subunits that are high in carbon-fluorine content. And the bigger the N value, the greater the stability. And when N is very large, it's called a polymer. It makes a polymer. So here, Teflon is the most stable CF compound that we know about. And I brought a sample of it so you can pass it around. There, it's a rod of Teflon here. It's very heavy, and it's very slippery feeling if you feel it. So it turns out it doesn't feel like anything else. On the surface, it feels kind of not slimy, but slippery, almost like frozen butter. And it's very strong. Ronald Reagan was known as the Teflon president, not because he looked like this rod, but because of the fact that everything could not affect him. The shape of PFAs is still a series of tetrahedrons like this, so they jiggle around like that. But if you look at Teflon, it has lots of structure inside it. And I wanted to explain something that's been puzzling for a long time. If you had all H atoms here and H, then it would be polyethylene instead of Teflon. And polyethylene is much, much less stable than Teflon. But what about the carbon? They both have carbon-carbon bonds. And so the fact is, when the fluorine is on the outside of the carbon-carbon bond, it stabilizes that bond. Essentially, it pulls electrons away, and the two atoms are then tighter together. So the fact of polymerizing carbon-fluorine units strengthens the bonds that are between them in a different interaction. PFAs, there are thousands and thousands of PSAs are known, but they also include, if they're not pure Teflon, which is this chain, then they include some amount of weaker bonds. And so you can get thousands, between N and M being any numbers that you can think of, you can get gazillions of molecules. The ones that are mostly used as stand-ins for MCLs, for contamination levels, are called PFOA and PFOS. And they're chains of only 10 atoms, and they have an group or a sulfonic acid group, which makes them much more stable than something like Teflon would be itself. And these essentially are used for when people make standards for PFAs, there's so many of them, they just pick on the smallest ones and apply the standards to those. So those are what PFOA is. So multiple molecules containing multiple CF bonds make very long-lasting compounds. And here's a preliminary list, but you've seen these all your lives. So non-stick cookware. How many people have non-stick cookware in their kitchens? Naughty. Okay, so stain-resistant fabrics. Almost everyone has seen Scotchgard. It goes into your carpets, it goes into upholstery, it goes into everywhere. Water repellent clothing. Gore-Tex is widely used to make waterproof and breathable fabrics. Lots of PFAs were used in food packaging. A lot of these are being reduced in usage and maybe eliminated. One of the worst problems is firefighting foams. So people that are busy fighting wildfires all over the place were exposed to PFAs. They're no longer exposed to PFAs except in airports, because gasoline fires in airports can mostly only be controlled with PFAs. And lots of cleaning products, waxes and polishes, contain PFAs to essentially make them last longer. And personal care products, lipstick, mascara, and nail polish from a few decades ago would also be problems. Okay, so now we are going to switch to Lily Neuwirth.
Yes.
Can you mute me? Ed, can you mute me?
It works. Yeah, we're all good.
You want to interact? Okay.
But so if you're wondering like how we got to this point where PFAs are in like basically everything that we like have in our homes, we have a little video for you called The Hidden History of PFAs. That's kind of like a crash course on like one specific company's impact, and then we'll go into more depth about like different companies and different materials.
It began in the 1950s when 3M began manufacturing PFAS chemicals in Minnesota.
Another fine product of 3M Company.
The chemicals, which are now known to be toxic, were used by 3M to make blockbuster products like Scotchgard, which were then sold around the world. By the 1960s, 3M began dumping chemical waste at multiple sites across the Twin Cities East Metro.
In the early 60s, that was a common way of disposal.
But in 1975, two independent scientists alerted 3M they found PFAS chemicals in human blood far away from its chemical plants, and they suspected 3M was the source. More than 20 years later, 3M issued this product safety memo, warning that the chemicals can cause cancer. But the warning label was removed that same year.
It may be the most insidious pollutant that man's created.
In 1999, Richard Purdy, a 3M scientist, resigned from the company and alerted the Environmental Protection Agency about the company's response to PFAS chemicals.
And you felt as an ethical matter, this is what you had to do, right?
Yes. Because I was a watchdog.
The very next year, 3M announced it would stop making some, but not all forms of PFAS. But the contamination continued to spread in the East Metro. And by 2004, high levels of PFAS chemicals were detected in the water supply in the city of Oakdale. Chemicals would go on to contaminate the drinking water for more than 170,000 homes. In 2006, the EPA eventually fined 3M $1.5 million for violating federal law for withholding its own studies that showed the toxicity of PFAS. Then, in 2010, in a landmark move, Minnesota's Attorney General at the time, Lori Swanson, sued 3M.
It was knockdown, drag-out litigation.
And the legal battle dragged on for years.
You can do whatever you want. You're going to tell me, put your finger down, put your finger down, put your finger down, don't raise your voice at me.
In 2018, 3M agreed to settle the lawsuit and pay nearly $900 million for the cleanup and treatment of water across impacted communities.
I am here to advocate for new legislation.
In 2023, Minnesota passed a law banning the sale or distribution of products containing PFAS. The law is named after Amara Strandy, who testified for its passage before she died from cancer.
See neighbors and friends who have also been affected by these toxic chemicals, and it's time for action.
Today, thousands of people are still impacted by the contamination, and it's costing millions to clean up the water supply in communities throughout the East Metro. Meanwhile, 3M has vowed to phase out production of all PFAS chemicals by the end of 2025.
Okay.
So that is just one example with 3M, and that was in Minnesota. And so now I'm going to take you to West Virginia for a second. So in 1930s, the business or the company DuPont actually invented a specific, like a branch of PFAS, and I don't think they were into use until like the 1940s. However, there were like a lot of flags raised when in the 1960s they found high levels of PFAS also in their workers' blood. So they created a little trial with some rats and discovered that it caused liver enlargement and some other organ failures and issues in their rats. But they were like, well, we're making money, the workers don't know about this, like it's okay, we'll keep going. So in the 1970s, the EPA is formed, and they present what's called the Toxic Substances Control Act, which is mentioned in the video as being violated. So this is a direct violation. They now, by the 1970s, were like, yeah, we know it's probably toxic. There's clear signs of like diseases being like arisen from it. So in the 1980s and the 1990s, they were like, we'll run a second trial, just to, like check it out. And they confirm that there are birth defects in their rats and multiple types of cancers that arise from exposure to PFAS in their blood. And at the same time, they're seeing these same symptoms and diseases arise in their workers. But again, still making money, it's okay. They don't need to know. So it's now been 50 years since their invention and probably 40 years since their actual like being put into use. And nobody knows they're continuously violating the EPA. And in 1999 is our first like exposure to PFAS in the law. So Wilbur Tennant is one of the cases mentioned in the video, but he had some, one sec. So he had some cows in West Virginia. He was a farmer, and they were drinking from this stream that was in direct runoff of DuPont's Teflon plant. Yes, thank you. And so what happened was these cows had insanely, they were like grotesque almost. They had like such, it was just like a lot of birth defects, and there was nothing good to come of it. And this man, Wilbur Tennant, was extremely concerned. So he brought them to court. And that is the first PFAS exposure. So this case was settled for multiple millions of dollars. But later, Tennant's attorney, Robert Billett, was like, I'm concerned. Nothing is really still being done on a large scale. So he sends a letter to the EPA, to the Attorney General, and to other states about Tennant's case. And in 2004, the EPA sues DuPont and for violating the Substance Control Act. It takes another 3 or 4 years to really make any action or find any settlements or like repercussions. So now it's been like 70, 80 years since the creation of PFAS and their exposure to workers and people and the community. So as you can see, it's becoming a widespread issue that is like kind of under the radar. But the repercussions are like a few $1 million, like $10 million were paid in damages. So they were forced to add water filtration systems across West Virginia, both private and public water sources needed them. And then they also paid $6 million in supplemental environmental projects. So like finding a chemical to replace the PFAS. But as you can see, it's still an issue we're facing today. And even though there were 70,000 class members, so people who would have been affected and were involved in the case, it's still going on today, this issue. So moving forwards, basically in the court case, a panel of 3 epidemiologists confirmed the probable link to kidney cancer, testicular cancer, thyroid disease, high cholesterol, ulcerative colitis, and a few other things, and preeclampsia. So throughout the 2010s was kind of a shift in the mindset of the general public of we need to solve this issue, you know, like it's a big deal, it's affecting us, we need a solution. But it was left to the states to decide how to manage it. So Pennsylvania, for us, was like, okay, we recognize that the EPA is concerned, so we will like set an MCL for PFOA and PFOS, two of the most known versions of PFAs. In Texas, however, like across the country kind of, you know, they were like, we'll rely solely on what the federal legislation is, which there's not a lot of. And currently, that federal legislation is under fire with our new administration. So a lot of the PFAS cases are being dismissed. But here is another example that my environmental science teacher brought to my attention. And basically, there was this crazy instance of 6 different players for the Phillies, one pictured on the left, David West, who all died from a form of brain cancer called glioblastomas. And it's not exactly a rare cancer, but it's rare to have clustered in such like a dense group. So, you know, that also arose some like big red flags for people. So in 2023, the Philadelphia Inquirer actually did this whole investigation where they bought this old turf, the veterans turf, which was AstroTurf, off of eBay, because after they'd removed it, they'd cut it up and sold it to people. So, so they bought all these different little like squares of this AstroTurf and they tested it for PFAs and we're like, well, what's gonna happen? And they find extremely high levels of both PFOA and PFOS. So obviously they go to other scientists and are like, can you, it's on there, it's okay.
Oh.
But they're like, can you just like confirm this link, you know, like we're a little concerned. And so they do confirm that there's over 16 different types of PFAS in this turf. So next, they can finally link this cancer to the deaths of the players and kind of explain what was happening in like in the team and the repercussions. There's some other examples of like different harms that were resulting from the PFAs. But they even confirmed like internationally just to, you know, definitely be right. And it was right. So, you know, like even here at home where you think, you know, you're just playing for a team for like 5 years, like it can have lifelong repercussions for you. So obviously this turf was like a big deal when it was built in like I think the 1980s. And they'd advertised it to high schools, to colleges, all these different places. They're like, our turf is great. It's a cheaper alternative to grass. So it's now everywhere. Not this exact turf, obviously. There's more rules now and regulations. But there is a big struggle between like high schools, for example, and like being transparent about what is in their turf. So when they asked like the Synthetic Turf Council that actually built this turf, they originally got no response for a while. Yeah, but later they did explain that there were no intentional additions of PFAs. However, we know they were present. And then finally, like there's examples also with the NFL struggling with turf. So the NFL hasn't had any examples such as the Phillies, but they obviously are like having different issues with turf also because it's easier to like slip on and causes their players injuries like physically. So, you know, they were getting involved, not to the same degree, but they were also concerned. So here is another one you may be familiar with, which is all different kinds of fast foods. So everything on the right and more has been confirmed to have PFAs in their packaging, in their Happy Meals, all kinds of things. Like up until the 2020, like 2022 range, there was just like, you know, PFAs on the loose. So yeah, so fiber trays also, lots of wrappers. This was a big issue for them. Obviously, there was a big mindset change across the companies. Again, from 2020 to 2022, they were like, we need to remove this from our packaging. Not good for anyone. So we see specific examples like Chick-fil-A and McDonald's. Like most of them were just like unintentionally, you know, there's PFAs in our wrappers because they like preserve the life of the wrapper and the food. But Chick-fil-A and McDonald's had actually intentionally added PFAs to their packaging. So they were like a big center of this whole shift. And to this day, a lot of them claim to be free of added PFAs. Not all claim to be free of PFAs as a whole. Most do. Chick-fil-A and McDonald's are more on the spectrum of added PFAs, but there is no intentional addition in our foods today, which is much better and much safer for everyone. So what's being done like today to change what's happening? So in 2023, this International Agency for Research Cancer, IARC, was part of the World Health Organization, and they determined that PFOA was carcinogenic to humans, so it did cause cancer. PFOS was possibly carcinogenic, and both are no longer manufactured in the US. That doesn't mean we can't have things brought over from international trade that is as free as like we are supposed to be, but it is a big step for us as a country. And in 2024, the EPA, who does not recognize these same like carcinogenic or possibly carcinogenic, they're not quite there yet, but they had this first drinking water standard, and they were like, you know, we'll set it in effect 2027, give you some time to fix everything. But currently they are fighting themselves and trying to go through federal court instead of like scientific channels to get this removed. So, you know, we're kind of struggling right now, but that's okay. Yeah. But there's quite a few locations that we're still focused on. Manufacturing sites, fire training, as Pop-Up talked about earlier, and some different landfills. But all in all, we are at least aware of them now and aware of the impacts. So here are some more wastewater treatment, which we'll go into in a second, with biosolids and drinking water. So biosolids are treated sewer sludge that is used as fertilizer and can transfer PFAs to the soil. And so there's one really large-scale sewer sludge on farmland incident going on nationally for us, which is the business Sinagro, and they have these plants that produce biosolids, which they have a 20-year agreement with Pennsylvania and some other states to then use and sell as fertilizer. So they work near the airports, and they sell about 16 million tons of this toxic fertilizer, and they make about $100 million annually. And they have all these different employers and business stakeholders, but they have over 900 employees, which you can probably expect to see somewhat similar results as to what happened with DuPont and 3M. And there are multiple lawsuits across the country right now, some of which are being dismissed, some of which are going further into court. But here's just kind of a map of our country right now and our regulations. Maine is currently the only one to fully like ban PFAs from all systems of like development. We are currently somewhere on the like high regulation, but not quite as strict as Maine. Most of the Midwest is very low regulation, if at all. But here, again, just some of the effects that we found. And, you know, like, obviously, we don't quite have a solution yet, but at least we are aware of it, and we know what's going on, and we can fix it in the future, hopefully. But yeah, here's Pop-Up again.
Oh, so can you hear me? Yes. Do you want to hear me? So the next thing we wanted to talk about was standards, MCLs, maximum contaminant levels for PFAS. And the situation in this is unbelievably complicated. First of all, the real answer for PFAS is 0. Any PFA is a bad thing, but practically the EPA can't say anything or do anything about that, or the WHO. So currently the WHO standard, these are numbers, the numbers here are in parts per trillion. So that's parts in a million. And it's remarkable that you can analyze using mass spectroscopy analytes that are in that kind of concentration range. So they're measurable. So the standard right now that's accepted as safe for PFOAs, the two stand-ins, remember, but we don't know what on earth the other guys are doing, is 4 parts per trillion. That's 4 parts in a million. And 10 for the PF for other related, more complicated examples. WHO has a standard of 100 parts per trillion, which they put in because they didn't know what else to do. Apparently, what you do is just go by the seat of your pants. When the true answer is 0, there is no real MCL possible. Right now, the EPA does not have any standard on the books. It's going to come into effect. The standards would normally come into effect in 2027. And of course, by then, it's quite likely that a lot of it will be reversed because of the administration. So the situation now is what kinds of drinking water is safe? And we'll talk about that in a little while. Meanwhile, how do you handle nonstick cookware? The New York Times science section yesterday scooped us and had a whole article on care and feeding of nonstick cookware. And the short answer is, if you don't heat them really hot, they're much safer. It says pop-up returns. I hope it doesn't show. It does. so you can see the transitions here are not smooth. So essentially, dry heating a nonstick Teflon-coated frying pan is really bad. It can produce something that's called Teflon flu, because people who do this regularly in factories making the stuff come down with symptoms of a flu. But the proper storage, what people aren't aware of is that mechanically the coatings break down, so that rubbing them with a knife or something like that essentially opens up the coating and starts its breakdown. So any damaged PFA coatings are really to be avoided, and you should replace them. And you should store them essentially not to. We have some old ones in our kitchen, which I was checking the other day and realized that we shouldn't have them. So there are lots of alternatives. There's lots of enamel cookware. There's lots of other things. Enamel cookware lasts a long time, but it still can break down. Stainless steel is not so easy to clean, but it's widely used in commercial kitchens, so you know that that's probably a standard. Go down to the bottom. Cast iron is fine. It's heavy. It lasts for a long time. You can kill people with it, but it's really very ponderous. But number 5, there's a uncoated cast iron, cast steel, carbon steel is much, much better. Carbon steel is much lighter than cast iron, and it coats the same way. You can put a coating on with oil and heating the oil, and you can reform the coating anytime it wears out. So essentially, it lasts forever as a non-stick device. So those are strongly recommended by our commercial division. How do you remove PFAS from home drinking water? The readings from all the PFA measuring sites in Philadelphia are around 4 to 5 parts per trillion. So they would be in the so-called accepted range that EPA will finally get around to announcing.
That's the drinking water out of our.
The drinking water out of Philadelphia, out of our faucets here, is essentially around 4 or 5 parts per trillion. And but as I recommended, the MCL for those is just a stand-in for all the others and essentially not really reliable. So how can you get rid of PFAS from your home drinking water? You can go and order a service that will bring in a very large-scale water treatment plant, Calgon and those other companies. But, and for example, our kitchen might at some point want to install a system like that to reduce it if it becomes a problem. And it is a problem. It's just a question of priorities. So activated carbon is an effective absorbent because it's highly porous and it absorbs almost anything, including PFAS. So it produces a huge surface area. You have to replace them after a certain amount of usage because they essentially all the sites fill up. But activated carbon is made from wood, lignite, and even coal, and it's called granular activated carbon. It's in masks and gas masks and so on. So here, as in our commercial section, is a breeder filter equipped with their high-level filters which trap PFAs as well as lots of heavy metals and things that they normally do. And so that's, it's convenient and it's easy to handle. Further research revealed this monster, which has got a glass container, which essentially then eliminates all possible microplastic problems as well as PFAs. And so essentially, you can get a year's supply of this for fairly small dollars. It's very inconvenient because it's very heavy and it's slow flowing, and they have to put back the salts because it filters everything so completely. So essentially, this is not recommended by our wire cutter team. So here's something interesting. Our gut microbiome is involved in removing PFAs from our bodies. So when 9 bacterial species were introduced into the guts of mice to make them human, to humanize them, the bacteria rapidly accumulated PFAs eaten by the mice, which were then excreted in their feces. So essentially, your diet is essentially protecting you from PFAs naturally and constantly. And something like a simple, adding bulk to the diet also would improve the ability to do this. So things like citrusel and those agents would be beneficial in this regard. This diagram shows you attempts. What about large-scale attempts to get rid of this stuff? And lots of companies, as you would imagine, are claiming to be able to do this. There's 2 approaches. One is to add water to the product, forget all of this complexity. You add water to it and then purify the water with reverse osmosis or any of the standard treatments. And then you get a very reduced volume of PFAs. What do you do with the reduced volumes of the PFAs? The answer is there's no way that's accepted today except for storing them in cement doesn't last because they'll leach out. Even in a landfill, they'll finally leach out. So even the stuff that you're filtering out of your home water filter is finally going to wind up in a landfill. But the other approach is to destroy the molecules themselves. And as you'd imagine, it requires enormous amounts of energy to do it. And the problem is that the products of the breakdown are fluorine gas and other things that are toxic themselves. So essentially, I think the only way to approach it is to treat it like radioactive waste and bury it in some container that absolutely will shield it for, 10,000 years or so, till our ancestors are no longer interested. And so here, takeaways. Better living through chemistry has some side effects, despite DuPont. Martha comes from Delaware. Elect officials who strengthen the EPA and CDC missions, because we've not been doing a good job of that. And essentially, it looks likely that they'll undo a lot of the regulations that are in place right now. As Lily said, get rid of your nonstick kitchen pans, especially the ones that are damaged, and don't sell them. One of the recommendations for getting rid of them was to put them on eBay, but there's obviously Republicans at work there. So essentially, get rid of them, just throw them away. And use a PFA simple filter system for your drinking and cooking water. That's a simple change and protects you. You can add metal containing ice trays for your refrigerator, and you can then have ice cubes that are free of PFAs. And
the metal ones are safer than the plastic ones.
Yeah, well, they don't leach plastic, right? Anyway, so that's the end of our talk. And so we are open for questions and comments. We'll think about.
I'm gonna go.
No.
Here you go. I'll go.
Thank you very much. That was interesting and informative. I'm glad you mentioned West Virginia. I'm from Cincinnati. And in 2018, there was a terrific film, Dark Waters, starring Mark Ruffalo, that was made about that exact issue. And I hope, I don't know if it's in our library or not. If not, maybe we can get it and put it there or show it on Channel 97 because it's really illuminating.
I've heard of that, and I think it's something we should get in the library.
It's very,
Yeah.
it's very good.
Mm-hmm.
Thank you.
A number of years ago, we were told,
Good.
a number of years ago, we were told that a military area in Montgomery County is producing enormous amounts of EPAs. I don't know if that problem has been addressed or not, but we were told to use water filters in our house. And there's particularly areas in Montgomery County that were major infected. Do you know anything? What's happened with that?
Any area near an airport is very surely contaminated with PFAS because it's the final anti-inflammatory that you put on a jet plane that's burning or jet fuel and so on. And the military, any military base is a hotbed of PFAS. And look what happened to these poor guys in Afghanistan. Anyway, so they've been there and they've been, doing their stuff for a long time. But I think any airport would, like Wings, is probably loaded with PFAS.
I have a question about prior to coming to Cathedral Village, I always used Brita. And then I got a refrigerator that has a filter on it and the water comes through the refrigerator. So is that filter in my refrigerator as good as a Brita?
Both of those filters are activated carbon and would pick up lead and improve. Brita advertises itself as improving taste, and that's a safe, advertisement. They do take lead, but until you use the high-class thing, they don't do PFAS. And some of them will take care of microplastics, but the one in the fridge would have to be changed every once in a while to keep itself active in both of those.
I still have my nonstick cookware in the drawer underneath the stove because I figure if I take it so I don't use it anymore, but am I not just recirculating the problem if I take them and they go into a landfill? It just feels like an incredible, insoluble problem that we have created.
Insoluble is right.
It's really scary. It's scary. So what should I do with my nonstick
Just
cookware?
take it to the dump.
Take it to
And
the
then they'll
dump.
go into a landfill, and then
it comes right back to
they'll
me
come
through
out over a long period of time. Yeah. Mm-hmm.
Neville, I'm concerned about,
Yes.
I'm over here, about our own kitchen and how much they know about this. I know that we have these new cardboard boxes and, I just was curious about whether Doug is privy to any of this.
So he's been concerned about microplastics, and that's an area we would require a separate talk. But he's moved now from using styrofoam, which is the worst offender of all possible plastics. It's loaded with chemicals as well as being incredibly easy to break down. So he's gotten rid of, as far as I can see, all the styrofoam. There's a problem with the green plastic containers. So recent research shows that heating any plastic produces enormous amounts more of microplastics than anything else. So heating those green containers is a bad idea. You should move them to a regular container as soon as you've gotten rid of them. And then not heating them helps a whole lot. They're made of a plastic that's very low in chemical content, bad chemicals, which is good, But the recent things that are sugar polymers are really ideal, except that they fill up landfills. You can't recycle them.
So the ones they're using now are in fact a great improvement.
Yes, much, much better than what we have been using. We
The
used to
other thing-
go and all the ice cream came in styrofoam, the soups came in styrofoam.
Right, exactly.
And he's
right.
gotten rid of all of that.
It's great. The other thing is that I read somewhere that using plastic bottles for water is really a bad idea because the leaching of from the plastic into the water is not good.
If you look at people that are being exposed to flooding or any disaster, they drink bottled water. And bottled water contains hundreds of thousands of particles of microplastics. And especially since they sit around for a long period of time, the stuff is gradually building up. So it's a bad idea to drink bottled water, period. Plastic bottled water.
Well, here's what's happening at our school kind of in relation to that. Our green club, so our like environmentally centered club, was actually helping to like phase out plastic water bottles from our cafeteria. And last year they added these like Dasani like aluminum cans basically. And they're pretty good alternatives. They have like minimal microplastics, if any at all, because they are metals. They're also very filtered, so that's something you could maybe suggest. Like almost every brand now makes aluminum can versions. Some screw on like are reusable, some are not. But in relation to water bottles, like a lot of people would still recommend stainless steel if you can get your hands on that. So like a Hydro Flask or any of those like types of water bottles is good. I would say if you're like, what's it called again? The brand, not
Well, this is our Nalgene.
Nalgene, yeah. So I think if your Nalgene is in good condition, then it's still like fairly safe to use, but I would say there are like slightly better alternatives. Personally, I don't know, like it's up to you, but I think there are like slightly better and worse versions of water bottles to use. Sorry.
Yeah.
Yes.
The microphone. Lily, they need a mic.
So I've not really been so familiar with sludge going on fields being a PFAS problem. When we use a garbage disposal here, that goes into the water stream and into the sludge, correct?
Yes.
So putting any food scraps through the garbage disposal is only adding to that. So the alternatives are using the composting service,
And it goes into
organic,
Yes.
right?
yeah, and essentially the standard the standard design of a landfill has huge big plastic barriers that these things will finally penetrate, and then they contain large amounts of stuff and generate methane. And the company we deal with, Waste Management, are primarily interested in landfills. They're not really terribly concerned about recycling. That's another problem. Do you want to go home and slit your wrists? No.
I think it's just trying to decide what you do with food scraps. If you put them in the garbage, it's better than putting them in the garbage disposal, correct? Because the garbage disposal goes directly into the water with the solid waste and then gets mixed in with PFAS and gets put on fields.
What are you disposing of? I'm sorry.
Food waste,
Food waste.
into your garbage disposal.
Yeah, so that goes into the sewage system, is reclaimed in the, refined and everything. And the solids from that are used as a form sludge.
Correct. And so that's not a good idea to
It's-
use your garbage
It's
disposal.
all we have available. I mean, unless you have a filter between you and the water supply.
Well, we can use the organic system of composting that is available here also, right?
Right, but composting, if you think about it, is generating soil, right? And it requires bacterial action. They can't break down PFAS. So compost,
Right, but I'm not talking about the PFAS in the food. I'm assuming there's minimal PFAS in the food. Am I wrong?
hopefully, but there are.
Uh-huh.
As far as I can see, it's pretty much Not, the concentration is probably low right now. But we'll only find out when
Right, but the
people.
best would be to compost it and use it as organic.
Right, that's what we rely on. We pay and compost.
Thank you.
I think the
Microphone.
I don't know the answer to this question, but I thought we weren't supposed to put meat in the compost.
Right.
So
No,
then I
no
mean,
meat, no dairy in ours, right.
I mean, there aren't a lot of good alternatives on what to do with stuff.
So meat goes into the landfill, yeah.
So I was relieved to learn that my digestive system is removing those PFAS.
Someone's on your side.
Yeah, that's, but however, if I understand you correctly, it's not eliminating them all so that over the course of a lifetime they build up. Is that correct?
Possibly. We don't know about the very biggest ones, with the very high N numbers. They stay around much longer, they're less soluble. They only analyze these two small guys, PFOA and PFOS, and they're stand-ins for everybody else, thousands and thousands of different molecules, each one of which could have a different effect. Okay. Okay.
Okay, well, thank you. Thank
You're
you
welcome.
very much.